Hi guys, welcome back to our channel, and in today's video we are going to look at the Lewis structure for SOCl2. It is a chemical name of thionyl chloride, and to determine its structure we are first going to look at the total number of valence electrons. Here sulfur has 6 valence electrons, oxygen has 6 valence electrons, and chlorine has 7 valence electrons. But we are going to multiply this number by 2 because there are 2 atoms of chlorine over here. So in total we have 26 valence electrons, and now that we know the number of electrons, let's place the atoms and their electrons. So sulfur here will take the central position because it is less electronegative than both oxygen and chlorine atoms. So place sulfur in the center, chlorine atoms on opposite sides of it, and oxygen atom above the sulfur atom. So once you have done that, show the bond between the atoms by placing a pair of electrons. So we are going to place 3 pairs of electrons, which means we are forming 3 single bonds and using up 6 valence electrons out of 26. The remaining electrons will be placed around atoms to complete their octets. So here you can see that each, like chlorine, all the chlorine and oxygen atoms have 2 valence electrons and just need 6 more. So we are going to place 6 valence electrons around chlorine, both the chlorine and oxygen atoms, and then we will be left with 2 valence electrons which will be placed on the sulfur atom. Now you might be wondering that as we have used up all 26 valence electrons, this might be the Lewis structure of thionyl chloride. But hold on, sulfur can have expanded octets, and whenever there is a molecule in which the atoms can have expanded octets, we always prefer to check the formal charges to see if it can accommodate more electrons. Expanded octets means that it can have more than 8 valence electrons in its outer shell, and that's the reason we always check for the formal charges when we come across such atoms in the molecules. So you can either use this formula that we are going to use here, or you can also use the formal charge calculator that we have linked in our description box below, and we are going to calculate the charges for a chlorine, oxygen and sulfur atom. Here chlorine has a total number of valence electrons 7, out of which 6 are non-bonding, 2 are bonding, giving us a formal charge of 0. As these chlorine atoms are identical, they'll have 0 formal charges. Now when we move to sulfur atom, it has 6 valence electrons, out of which 2 are non-bonding, 6 are bonding, giving a formal charge of +1. And similarly for oxygen atom, we have 6 valence electrons, out of which 6 are non-bonding and 2 are bonding, which gives it a formal charge of -1. So one might argue that it is fine if there are charges on sulfur and oxygen atoms because the net charge is 0. But if you look at this atom, sulfur atom is less electronegative than oxygen atom. So it is not possible that sulfur atom will have positive charge, and so one might argue that this structure could be the accepted Lewis structure for SOCl2 as the net charges on this are 0. But whenever we are writing the Lewis structure for any molecule, we try to come up with a structure in which atoms have charges closer to 0. So we can try doing that by shifting a pair of electron from this oxygen atom in between sulfur and oxygen atom, and doing that we will get a formal charge of 0 on all atoms. Like even oxygen will have the formal charge of 0, sulfur will have a formal charge of 0, and chlorine atoms as it is had a formal charge of 0. We can also confirm it by calculating the formal charges again, either by using this formula or the calculator link in the description box below. And now this is the Lewis structure for SOCl2, in which sulfur forms single bonds with both the chlorine atoms and a double bond with oxygen atom. I hope this video helps you to understand the Lewis structure of SOCl2, and for more such videos on Lewis structure, molecular geometry, polarity of the molecules, make sure to subscribe to our channel, and thank you for watching.